Hello, everyone, and welcome to OpenCV Live, episode 159, if you can believe it. I'm Phil Nelson, your co-host with the co-most, the second banana, who is second to none. I'm also your plus one and only. It's Mr. Nelson, if you're nasty, but you, my dear friends, can call me Phil. Flying solo today as as Dr. Satya Malik is on assignment, but in his place, we do have a professor on today's show, which I'll be introducing in just a moment. This week, we're bringing you another challenge to test your skills. The IEEE Low Power Computer Vision Challenge is an annual competition started in 2015 with the goal of improving the energy efficiency of computer vision for running on systems with stringent resource constraints, edge devices, things like that. To tell us about the three tracks of this competition is Professor Young-Sang Liu, a fellow at IEEE, distinguished visitor of the Computer Society, distinguished scientist, and distinguished speaker of the Association for Computing Machinery. He brings with him three students today, Zhao Ye, Oolong, Zhen Yao. We'll introduce them in just a moment. But first, of course, I'm here to remind you of a few things we do every single episode of this show. The first of which is a giveaway to you in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on the presentation from our distinguished guests. And the first person to answer that question correctly in the Zoom chat window will win the OpenCV course of their choosing. You can find out what courses are available from OpenCV by going to opencv.org/university. That's opencv.org/university. Even if you don't win today's trivia giveaway, maybe invest in yourself, invest in your education, upskill, get paid more, get a new job, get better at your current job with OpenCV University courses. In case you all needed a reminder, OpenCV is a nonprofit organization that ships a computer vision library that is open source, permissively licensed under the Apache 2 license, which means that basically you can use it for whatever you want and you don't need to pay us anything. This is important for several reasons. The first of which is that it means that OpenCV depends on the support of our members and partners. You can see we've got a few new ones on the list in the last few months, and we really appreciate like our friends at Qualcomm, who have something to do with this episode. In fact, they are the sponsors of this IEEE challenge that we're talking about here today. Speaking of challenges, OpenCV also has one of our own going on right now. The Perception Challenge for Bin Picking is open. You can head over to bpc.opencv.org to check that out. Sign up to participate. Over 1,100 of you have already signed up. We've got 300 teams participating already. It's going to be a really fascinating challenge. We can't wait to see what you do. The submissions open up relatively soon, and we're really excited about it. If you work for a large organization, they may do donation matching. That means that your company, if you give some money to OpenCV or even donate your time to OpenCV by working on the library, they will match your donation. Companies like Facebook and Google and Apple sometimes do this, or Microsoft, for example. Check out if you have the Benevity Causes system. If you have that, then they will probably match your funds. And as a reminder, OpenCV is a 501c3 registered nonprofit organization in the United States, which means that if you do donate to OpenCV, it's very likely tax deductible if you are in the US. If you work for a company or you run a company, consider becoming an OpenCV member organization if your organization depends on OpenCV to make the stuff that they make. We have three different tiers: bronze, silver, and gold. You can find out all about them on the OpenCV donate page. Check out the brochure for membership, etc., etc. You can also sponsor us on GitHub. Go to github.com/sponsors/OpenCV to check that out. It's $9 a month. You will get listed on the current sponsors. There are 14 phenomenal human beings on that sponsors list right now. We really do appreciate every single one of them. I'm giving them their 15 seconds of fame here as I go down the list. Thanks so much. Especially to our longtime donors there, the homies over at RoboFlow, Nick Libertini, Blue Jay. They've been doing this for months and months. We really, really appreciate it. Y'all are the absolute best. Having said that, I think now is a great time to start our presentation. Professor Liu, please tell the folks who you are and let's get to it.
All right. Thank you very much. I'm sharing my screen. Theo, can you see it?
Yep, it looks great.
Okay, thank you very much. My name is Yongxiang Lu. I'm a professor at Purdue University. It's a great honor to have this opportunity speaking here. This is the 2025 Low Power Computer Vision Challenge. I'm speaking here with 3 students. This year's challenge is organized by 3 universities: Purdue University, Loyola University Chicago, and Lehigh University.
Okay.
I will give a brief overview of the history of IEEE Low Power Computer Vision Challenge. Then I will explain the 3 tracks of this year's challenge. Then the students will explain the tracks in more details, including demonstration about how to participate and submit your solutions. The first track for this year will be image classification for different lighting conditions and styles. The second track will be open vocabulary segmentation with text prompt. The third track will be monocular depth estimation. You can find more information at his website, OpenCV.ai, lpcv.ai. If you go to this website, lpcv.ai, you can see this year's competition, and we are very fortunate to have a sponsor of a Qualcomm this year. This competition is also sponsored by the Computer Society of the IEEE. At its website, if you go a bit lower, you can see the registration tab and register for this competition. Why do we want to do low power computer vision? There are many examples. Here, I will just give you 2 scenarios. The first scenario is you want to analyze an image or video you have taken with your mobile phone. For many reasons, you may not want to send this data to the cloud. One example is you may want to protect the privacy of your data. The second scenario is you may be in a place where you do not have high-speed wireless network connections. In these cases, you want to have the capability of running computer vision programs on your mobile phone, and it is a very resource-limited device. In the example on the right side is an image taken by a drone. Imagine after a disaster, in this case, it is flooding. There may be no wireless communication infrastructure for the drone to send images to the cloud. Therefore, the drone needs to analyze the image and provide useful information to the first responders. Drones usually have very small computers, therefore, low power computer vision is very important. These are just 2 of the examples where low power computer vision is important. Even if you have access to large computers or the cloud, low power is still important because consuming too much energy is going to be harmful to the environment, as well as taking too much time for the computers. This year is actually the 10th year of the IEEE Low Power Computer Vision Challenge. This challenge started in 2015. In the first 3 years, these are the on-site competitions organized with 2 different conferences. In 2015 and 2016, the competition was co-hosted at the Design Automation Conference. In 2017, the competition was co-hosted at the CVPR. As you can see from the number of teams, as we have heard from multiple teams that they wanted to participate, but they were not able to travel to the conferences. In 2018, we moved the competition into an online competition, and people can submit their solutions online without traveling. For the winners, we also organize workshops in conferences so that they can present their solutions in the conferences. Since the competitions are online, we can see significant growth of the number of teams over the years, and the number of submissions also grow substantially. We are very fortunate to have many sponsors over the years. This includes the National Science Foundation of the United States, Google, Facebook, NVIDIA, Qualcomm, multiple societies of the IEEE, and the Special Interest Group of Design Automation in ACM, as well as some other companies such as Xilinx, MediaTek, and Elan Electronics. This slide shows the winners over the years. The winners spread across multiple countries and include both industry and universities. In some cases, they are collaboration between industry and universities. You may be curious why we have multiple winners, more winners than the number of years. And the reason is in some years, we have multiple tracks. Therefore, we have more than one winners in those years. You may also notice that Qualcomm is this year's sponsor. They were actually a winner a few years ago. They find the significant value of participating in this competition. And this year, they want to sponsor the competition.
That's great. How come none of the OpenCV winners are sponsoring us? Come on.
So this slide shows the awards for the winners. We will have the 3 tracks. Each track will have 3 awards. The first award will be cash of $1,500 plus an AI PC from our sponsor. The second award will be $1,000, and the third award will be $500. On the right side, you can see the timeline. Registration has already opened, and submission window will start on March 1st. There will be a month of a submission time. That means teams can find out how good their solutions are, make some improvement, and submit again. We'll announce the winners on May 1st, and the winners will be invited to present their solutions at this year's CVPR in June. We already have a workshop prepared for the winners to present their solutions. This is the organizing team, including the professors, the students, as well as researchers and engineers from our sponsors. These are the 3 tracks. The first track will be image classification for different lighting conditions and styles. On the right side, you can see some examples of images. Since we want to run this on low power devices, the submission will be running on Snapdragon 8 Elite processor. The text will be image classification, and there will be 64 different categories. As you can see, the images may have a normal lighting, low light, or backlight. The second track will be a computer vision challenge with text processing. This is open vocabulary segmentation. There will be an image plus some kind of text description for segmentation. Consider this image with multiple colors. The image will be given together with a text description such as purple vantage car. In this case, the segmentation should be performed only on the purple car. The input will be RGB images plus text description, and the output should be the binary instance mask of the object that meet the description of the text. The third will be depth estimation. This will also be running on Snapdragon 8 Elite. The input will be an RGB image. The output will be the relative depth from the input pixels. Now I'm going to give to Zihao to explain track 1.
Thank you, Professor Lu. I will give a little more detail about the track 1. So the vision task for track 1 image classification is classifying images for different lighting conditions and styles. And like Professor Lu just mentioned, the hardware where we'll be evaluating the submissions is the Snapdragon 8 Elite, which will be available on Qualcomm's AI Hub. We also have released a sample solution on our GitHub page. And the model input for the sample solution is the RGB image, and the resolution should be 224 times 224, and the output will be the class index of the top 1 prediction. We have also released a public data set for the participants to use. It will be 100 RGB images from the 64 out of 80 COCO classes we have selected, and it was made with images available on the internet, as well as some images taken by ourselves. And of course, the images has different lighting conditions and styles. For example, for the styles, we have indoor, outdoor, and synthetic images generated using Stable Diffusion. And as for the lighting, we have normal light, backlight, and the low light and backlit. So at the bottom, we have some examples from the public data set. And now I'll move on to the evaluation part of the track one. So in track one, it will be a two-stage evaluation. We'll consider two aspects of the models, the execution time and the accuracy. So in stage one, for all the submitted models, we will run a profile job on Qualcomm's AI Hub to measure the execution time for the model, and only for those with a shorter execution time or faster execution time than the sample solution we have provided will be considered as a valid solution and move on to stage two. And in stage two, we'll measure the accuracy of these models, the prediction accuracy. So for the valid solutions, we'll run the model with our private testing data and rank the results accordingly. And the final score on the leaderboard will be calculated with accuracy divided by execution time. So the baseline model we have published is the MobileNet V2 with a small modification to classify the 64 classes we have selected. And it was also available on our GitHub page. And this is all for track one. Thank you very much. I will give it to Jen.
Well, thanks, Zihao, for introducing the track one. Next, I'm going to share some basic information about the task, about the evaluation strategy, about the dataset, and also about an example of track two, which is referring segmentation. It is an vision task of instance-specific segmentation given the text prompt, and all the models will be measured by on a Snapdragon X Elite mobile chips. And we have released our sample solution as well as some a code guide for compiling our model on in a given GitHub repo. In terms of the input and output of this model, the input will be the RGB images with the size of 1024 by 1024 with text description, and the output will be binary segmentation mask of the original size, highlighting the referred object. So on the bottom, we provide an example indicating the input and output of the model. The input will be 3 ping pong balls, and the text prompts will be either the green ping pong ball or the ping pong ball with no text or the ping pong ball under the other balls. So the output will be specifically the green one, and it will not include other 2 ping pong balls. Well, in terms of the evaluation dataset, for the training set, we do not limit specific training data for this track, and participants are free to use any accessible data sets. For the test set, we collected about 1,000 RGB images from around 200 classes, and they are randomly selected from various public sources. And we provide another 2 examples on the bottom. So in the example 1, this is an image of multiple cars in the parking lot, and the text prompt will be either the red bus or the double-decker bus without roof, or the double-decker bus next to the blue bus. And the output will be the specific red bus, and it will not include other buses or cars. And in the example 2, the image show a giraffe and also a car, and the text prompt is either the giraffe has a white body with brown spots, or the giraffe is looking down at a gray car, or the giraffe is standing at the center of the image, and the output will be the giraffe only. And from these 2 examples, we can see that the text prompt will include some information related to the position or the color or other semantic information. So next, based on so how we do the evaluation is that we adopt 2-stage evaluation strategy. Well, for stage one, the latency, we will use the Qualcomm AI Hub to measure the model latency performance on the real mobile chips. And all the simulated model will try to use the AI Hub, and a submitted model will be considered a valid solution only if it outperforms the latency of the provided baseline model. And for the stage two, the quality, for all valid solutions, we will calculate the mean intersection over union, which is mean IOU, across all test data and rank the results accordingly. And the mean IOU is a very popular evaluation metric in the segmentation task. Please note that the final ranking will be determined based on the mean IOU performance among all valid submissions. Okay, next for our baseline model, we use the X decoder, which is published on CVPR 2023 by Microsoft. And we provide our the original GitHub repo link on this page, and also the model link we uploaded to the Qualcomm AI Hub. So all the participants are free to use all the links to access the original repo or the model we upload. Xdecoder is a generalized decoding model that can predict pixel level segmentation and language tokens seamlessly. And for the training data, we use Coco 2017 to train the Xdecoder. And for the train weights, we also provide our train Xdecoder weights in our previously given GitHub repo. So for the implementation details, we adopt Focal T as the backbone, and we use the clip tokenizer to generate the input ID embedding and also the attention mask embedding given the text prompt. And thus, for the specific input, it will be input tensor and also the stacked text embeddings combining the input ID embedding and attention mask embedding. Well, next, we will provide an example of how we test our single image on this model, Qualcomm AI Hub. So basically, we provide an image on the top right, which is a dog, and we also provide a text description dog. Well, for the text prompt, as we mentioned before, we will use clip tokenizer to generate the input ID embedding and attention mask embedding as shown here. And we will stack the input ID embedding and attention mask embedding into a text embedding. And we will feed the image tensor as well as the text embedding to the model. And the output is on the bottom right. It will be a banner mask indicating the referred object, which is the dog we provided, and we show here. Well, that's all for the track 2.
Hello everyone. I will go through
Just
the
let me
details.
butt in there real quick, Bolong. Sorry. As a reminder out there, folks, we are taking questions from you in the audience. So use the Zoom Q&A button at the bottom of the screen if you've got questions about today's presentation, and we'll do our best to answer them a little bit later in the show. If you're not watching on Zoom, use the chat system wherever you're watching on YouTube, Twitch, etc., and we'll do our best to answer questions there as well because I am watching those chats. Go right ahead, Bolong.
Okay, I will go through the details of track 3. The vision task for this track is monocular relative depth estimation. Participants need to design model to predict the relative depth map given an image. The submit model will be evaluated on the mobile device. The input to the model is the RGB image in VGA resolution, and the output is estimated relative depth in a range of 0 to 1 for all input pixels. Each model should predict a single output with one channel, so the shape will look like batch 1, height, and width. For the evaluation dataset, it has 2,000 images captured in various indoor and outdoor scenes under different lighting conditions. For example, normal and low light. We captured these images using a range of mobile devices. Here we list the distribution of the data in this table. For each light condition, we provide 500 images for either indoor or outdoor scenes. Besides the RGB image, we also provide a corresponding depth map and confidence map. The depth map indicates the depth of each pixel in the RGB image, which can be considered as the ground truth, while the confidence map shows the confidence level of the corresponding pixel in the depth map. I will give more explanation about the confidence map in the next slide. So unlike other challenges or benchmarks, our evaluation dataset considers the confidence scores of depth value in the confidence map. Here we show a picture containing the RGB image, visualized depth map, and visualized confidence map from left to right. In these visualized samples, the black areas of the confidence map indicate low confidence, while the white areas indicate higher confidence of the depth map. So black to white means that the confidence scores will become from low to high. And the predicted depths in the black areas of the confidence map will not be considered when calculating the accuracy scores. In this case, this approach aims to minimize the negative impact of errors in the depth ground truth on the evaluation scores. Next, I will introduce the evaluation part. The evaluation follows a two-stage evaluation strategy. First, all submissions will be profiled on real mobile devices. The submissions will be considered valid if its inference speed on the target mobile device is faster than 30 milliseconds. In the second stage, we will calculate image-based metrics and point cloud-based metrics based on the existing works. Valid solution will be ranked based on a single score or weighted combination of multiple scores. To be noticed here, we will only consider predict depth at locations with high confidence scores in the confidence map. And the predict depth map, which runs from 0 to 1, will be rescaled based on the median value of the ground truth depth before calculating the final accuracy scores. We provide a simple solution to show how participants can modify their model for this track. The baseline model is using depth anything v2, and the details could be found in the provided GitHub repo. Here we want to emphasize some important points for the submitted model. The model will take input with the shape of batch, channel, head, and width. And the input images are in RGB channel order with a range of 0 to 255. Participants need to handle image pre-processing within their models, for example, the image normalization. The models are expected to generate a tensor with a 4G output, which is batch, 1, head, and width. The head and width should be the same as the input the resolution of the input RGB image. And the final output of the models should be in range of 0 to 1 before rescale. That's all details for track 3. Thank you.
Okay, I'm going to give back to Zihao. He's going to explain a few more technical details. I'm going to stop sharing so Zihao can share his screen.
Thank you, Professor Lu and Jen and Boer for your introduction on the other two tracks. So now I would like to go over the participation pipeline of this competition. And I also saw in the chat, there's a question asking about the evaluation board. So actually for all of the chips, and actually also includes many other chips mentioned earlier in the introduction, they will all be available in Qualcomm's AI Hub, which is a free platform. You can check out their website. That's a platform where you can upload your model, run your model, and therefore for this competition, you don't really need to try to purchase any kind of hardware device. You can just use Qualcomm's AI Hub. All right, so now I'll go into the pipeline for the participation. So of course, first step will be registration. And since we'll be using Qualcomm's AI Hub, we actually ask the participants to register on 2 different platforms, Qualcomm AI Hub and on our website, lpcv.ai. I would recommend do the registration on Qualcomm's AI Hub first, because your AI Hub account email will be needed to register on our website. So on Qualcomm's AI Hub, you can easily find the login sign up button on the top right, and follow their instructions to register an account. And on our website, on the homepage, you can find this register button. It will bring you to a registration form you can fill out, and there will be an agreement at the end to sign for all of the members in the team. But this form is all you need to register. So once you have registered, the next step will be, I would highly recommend check out the sample solutions. Just get familiar with the requirements, the hardware requirements, or the input-output format, etc. And once you're familiar with those, you can start building and testing your model on your own device. So once you get a model ready on your own device, you have tested and run it locally, you can move on to AI Hub and upload your model and do some testing on AI Hub. So the first step will be uploading and compiling your model on AI Hub. And then you would, for testing, you would upload a data set, either using our sample data set or use your own training data set. And then on AI Hub, there will be 2 different types of jobs that can help you test your model, the inference job and profile job. What the inference job does is run the model with the dataset you have uploaded, so you can get an accuracy score on AI Hub. The profile job, on the other hand, it will run your model multiple times with some dummy inputs to measure the execution time. So the inference job and profile job are exactly the same thing we'll be using to evaluate your model on our end. And so once you have tested your model or you're confident with it, you can move on to submitting your model on our website. You'll fill out a submission form on our website, which shouldn't be available at the moment, but once the submission window opens, you'll be able to see them. This is a example of the submission form. We'll ask very simple questions: your team name, your email address, the email address you used during the registration, and most importantly, the compiled job ID. So we can find your model and access it. So we have a very important point is that for submissions, you'll have to share the compiled job with this email address, lowpowervision@gmail.com. That's actually the official email address for our competition. Only that way we can access your model for the evaluation. So once you submit a form, we can access your models and evaluate it on our server. And for the valid submissions, we'll publish the score on the leaderboards on our website so you can get some feedback. And once you get the score, you can basically repeat this build, test, and submit process during the submission window. So now I would like to show some demo example code to use AI Hub. So just like I just mentioned in the flowchart, the first step will be compiling the models. So for all of these codes I'll be showing today, they will also be available. A clean template version of all of these code will be available on our GitHub page. So yeah, let me get back to the code. So the first step will be compiling a model. There are several to-dos you have to fill out in the template. So of course, the first step will be filling out defining the device according to your tracks. Since each track, they have a different device. And the next one will be defining the input shape, which is also different for each track. And the next to-do, of course, is the most important to do is to build your model. Here, I will be downloading a model from AI Hub that I've already uploaded before using this get model function. For you guys, it will probably be where you write your actual code for your model. So these are basically what you need to do for compile a model. I will run this code, and it should automatically upload your model to AI Hub and compile it, and it will provide you with a compile job ID. This is what you need for the submission form as well. So it's very important to write this down somewhere. So once you compile your model, you probably would want to move on to testing. So this code will help you upload your testing data set to AI Hub. So there are two to-dos for this part. Of course, you have to define the path to your images or your input. It will be slightly different for track 2, but yeah, the path to your input. And you'll also have to define your target size or the input size. By running this code, it will upload your images or input to AI Hub. The example I'll be using today is actually from our sample data set for track 1. It's an image of an apple. And as you can see here, it will provide you with a dataset ID, which you can use later to extract your model for testing. Your dataset, sorry, for testing. And once you have your compiled model ready and your dataset ready, you can move on to testing. I'll first show the inference job, which is actually running your model with the actual dataset for you to get an accuracy score. So similar to compile jobs, you'll have to define your target device, which will be different for each track. You'll use the two IDs we just talked about here to get your model and your dataset. And by running this code, it should submit a inference job request on AI Hub. I will terminate this so we don't have to wait for the job to finish. But at the bottom of the code, you can probably see there's example output I've run before. It will provide you with a job ID for you to track your results. Also, it will help you to extract the output from the previously run job using this get job and download output data. In this example, I will extract the results from a previously run job, and as you can see here, our sample solution was able to correctly predict the image as an apple. And the last one will be the profile job, which will run the model with some dummy inputs for multiple times to measure the execution time. As you can see here, there's option here you can change. This is how many times it's going to run your model. By default, it should be 100. So there are two to-dos here. Similar to the compile job and inference job, you have to define your target device. You have to provide it with the compile job ID. And by running this code, it should provide you with a execution time. And so this is all for the demo. Hopefully, you'll get a better understanding about AI Hub and how to use it. And now I will move on to some frequently asked questions and answers for this competition. So first question, can companies participate? And the answer is yes. And can a team include members from both companies and universities? And the answer is also yes. And can a team include only a university? And the answer is yes. And what's the limitation of a team size? How many members can you have on a team? We actually don't have a limit. You have as many members as you want. So the next question: how many times can a team submit? The answer is as many times as the team wish. We will do the evaluation once per day. So we'll only consider the last submission from the previous day. So you can submit as many times you want. The later submissions will just override the previous submissions. Is open source needed for these solutions? The answer is no, but for the winner teams to receive the awards, the solution has to be open source. How many awards will be given? There will be 3 awards per track, so a total of 9 rewards. The next question is, can winners present their solutions? Like Professor Lu just mentioned earlier, the winners will be invited to present at a workshop in this year's CVPR conference. And the next question, probably one of the most important questions, where can you ask questions? Please feel free to join the Slack channel. You can find the link, I believe, both on AI Hub and on our website. There will be a channel there, sub-channel, specifically for LPCVC, where you can ask questions. Will the training data be provided? The answer is no. We'll provide a sample data for each track. A very small sample data is probably not good enough for training. These data are just to give the participants an overview, a rough idea about the input data. So the participants can use any data they like for training their own model. So the next question is, can a team participate in multiple tracks? The answer is yes, you can participate in all 3 tracks or just 1 track. This will also cover the next question. So you can participate in any of the tracks or in all 3 tracks. So the next question is, who can submit a solution? So during registration, in the registration form, we'll ask for a primary contact email. So during your submission, we'll also ask for email. Please use the same email for both forms. But for the actual submission on AI Hub, when you submit the model and do the compilation, any one of the team member can use their AI Hub account to do that. So the next question is, can a team register multiple accounts on AI Hub? The answer is yes. AI Hub is a free platform. Anyone can register on it. Even if you're not interested in participating in the competition, you can check out that platform. There are many different chipsets that are available for you to test your model. The next question is, how will the sample solution be used? The sample solution is the qualification, like we have mentioned in the introduction for each track. So the solution will only be considered as a valid solution if it's better than our sample solution. Yeah, I believe that's all for the questions and answers. So please feel free to check out our website for more information for the competition for each track. And we're welcoming everyone to participate and showcase your creativity. Thank you very much. I will give it back to Dr. Lu. Thank you.
All right, thank you. I think there are some questions. Phil, do you want to moderate the
Yeah.
questions?
Yeah, I can do that. Go ahead and unshare your screen there if you don't mind.
Yep.
Hey, yeah, so what we'll do here first before questions is our special giveaway. As folks who watch this show know, we give away a free OpenCV course of the winners choosing every episode of OpenCV Live during our trivia segment, which is happening right now. Those of you in the Zoom chat, that's at opencv.live. If you're not in Zoom, you can get there by going to opencv.live. I will be asking a trivia question based on the presentation from our illustrious guests, and the first person to answer that question correctly in the Zoom chat with their messages sent to everyone, not just hosts and panelists. There's a little button you got to click there to make sure that happens. Will win the OpenCV course of their choosing. You can see what courses are available by going to opencv.org/university. In fact, even if you, maybe you're in between jobs, you don't have a lot of money to spend, there is a new free course, a free PyTorch bootcamp available on OpenCV University. Here's a quick screen share to give you all a look at that. You can find that on opencv.org/university. It's a 5-hour PyTorch bootcamp, absolutely free. Go ahead and give that a look. Also, for whoever was asking before, the films are Strange Days and Hackers, both of which came out in 1995, weirdly enough. So there's that. If you have won trivia in the last couple of months, please do not answer and give someone else a chance to win their free OpenCV course. Get ready to answer in the Zoom chat, everybody watching out there. So the low power challenge here has been going on for a few years, and at first it was in person. In what year was the first challenge held, and how many teams participated? Both. You have to answer both in one message on there, folks. Both in one message. Come on. Oh, you're so close. Everyone's so excited. They're fat fingering. Ah, it looks like we got it. All right. Some of y'all thought you were in my head, and you were half right. You were half right. The answers we were looking for were 2015 and 10. I'm looking through the chat here. It was fast and furious in there. A lot of people posting 2015 by itself, and that is not quite correct. It looks like on my screen, the first person who sent it to everyone and was correct was Narpat Kumar. Congratulations. Please send one email to phil@opencv.org with the course you would like. You can see what courses are available by going to opencv.org/university. Go there, pick one, send an email to Phil, and we will see that you get your course. Congratulations. And thanks again for joining us. We have a few more questions from you all and a few more minutes to answer them. It sounds like a sweet deal. So let's take a look at what people have been wondering about during this presentation. Over here on Zoom, we have a question which we get pretty much every week, which is, will the recording of this episode be available? Yes, it absolutely will. It will be available on our official YouTube channel immediately following the show. That's youtube.com/@OpenCVOfficial. You'll be able to find this exact episode as soon as the show's over. We'll also update the show notes there and add some of the links like the GitHub and the website and things. So you have all of the information you need to participate in this extremely cool competition right there. Got another question here from Zoom. It says, in track 1, do you want teams to enhance the low light images in the test set, or would you prefer them to classify images under different lighting conditions? Professor Liu?
How do you want to answer that question?
Yeah. So the answer is it's really up to you, right? If you think enhancing the low light images can help you achieve a higher accuracy, you can feel free to do that. You can include that in your model. But after all, the final score is accuracy over execution time. So you will have to decide how you want to do the trade-off. Hope that answers your question.
Yes, this makes sense. So you're saying there's no restriction against doing this. If it works better on your workflow, that may be a good way to go, but it's not necessarily something you have to do. Damien here in Zoom would like to know what are the required file formats for uploading these submissions. There's a bunch of different standards out there, ONNX, etc. What are you all looking for on these specifically?
I wouldn't say it's a file format because we're not actually asking for any files. You actually compile the model on AI Hub, and you will receive a compiled job ID, and that's what you will submit to us, and we'll access your model from there. For track 1 and 3, I believe TF Lite is, so there are different options to compile the model. You can look them up in the documentation for Qualcomm AI Hub. But for track 1 and 3, I believe TF Lite. And for track 2, maybe Jen is slightly different. I believe Jen can answer that part. Thank you.
Yeah, for track 2, actually, we provide a sample solution based on how we compare our model based on the Onyx format, as you mentioned. Yeah, so basically it's correct. We use Onyx for the track 2.
Sounds great. This one is actually from me for Professor Liu. Why low power vision? Like what really drew you personally to this challenge and this problem specifically?
Oh, well, thank you. Actually, believe it or not, that was a joke between me and the vice president of NVIDIA 12 years ago when we met in a conference. And you probably know that deep learning became very popular starting from 2012. So I made the executive of NVIDIA in a conference, and he was saying people buying NVIDIA GPU crazy in 2013. And he said, can we do something different? And I said, can we ask people not to buy NVIDIA GPU by making them more efficient? And then NVIDIA said, we'll be the first sponsor. Let's do it. So interestingly, you probably know that since then, at the beginning, people did not think low power would be important. But now low power is so important. You probably have heard some technology companies are thinking about buying nuclear power plants. Energy has really become a dominating factor of the success of machine learning. So it started as purely a joke between me and the NVIDIA, but over the years it survived and grow, and now is what we have.
Yeah, that's great. Hey, many great things in the world have started out as a joke and became very serious. I think I love that story. Can you talk a little bit more about the CVPR workshop as well? Because we've talked about this with the other OpenCV competitions.
Yes.
Being a part of a CVPR workshop is a big deal. Like in this industry, there's not many honors that are higher really. So please tell them a bit about that.
Okay, so since 2017 we moved to CVPR as our platform, and every year we organize a workshop as a place where the winners can present their solutions. Also, we invite speakers as leaders from industry as well as academia to share their experience. So we have been doing that for many years, and this year again we have the tradition, and our workshop has already been accepted by CVPR. I don't know the dates yet, but it will be one of the workshops in CVPR. Last time we had the efficient computer vision workshop at the CVPR, we had something more than 200 participants. And this time we'll see how many people will be there. This will be a great opportunity for people to go there and make friends and try to exchange different ideas, solve difficult problems together. So this year, CVPR will be in Nashville in June. And if you want to participate, let me know. We can all hang out together.
Yes, OpenCV will be there again at CVPR we'll have a little booth space, and of course we'll be presenting at our own workshop as well, alongside our friends at Intrinsic for the Perception Challenge for bin picking. Speaking of events, one event I want to remind people about is coming up a little bit later this year. It's called Display Week. It's a very popular event here in San Jose in the Bay Area. This year, though, there is a new thing you can check out here. So if you go to the displayweek.org website and scroll down a bit, you can find that there's this new one-day event called the Conference on Computer Vision and AI. I would recommend that you stay tuned for more information about this mysterious event. We will talk a bit more about this with you later on, so go check out displayweek.org and keep your eye on your OpenCV newsletter email address out there, everybody. Thanks so much for the presentation here, everybody. I think it went fantastic. I was a little bit nervous when I saw, 4 guests. I thought it might be a little bit tough, but you've all been so good about muting out when you're not on screen. Really, really appreciate that. Thanks so much for everybody watching out there. As another quick reminder, we have another show next Thursday, 9 a.m. Pacific time, and our guest will be Matt Flagg. This is going to be a really interesting one and different than a lot of our recent episodes. We're going to welcome Matt Flagg from Code 19 Racing, the world's first autonomous motorsports team. Super excited about this episode. Go check that out. You can find us on the same places that you watch everything else, every other episode of OpenCV Live. It's opencv.live if you want to join us on Zoom. It's at OpenCV Official on YouTube. It's OpenCV Official on Twitch. And, we'll keep you informed. So please check that out later. Any final thoughts for the audience, Professor Liu?
Thank you. Thanks for this opportunity. I really appreciate the participation from everybody. And please join the competition. Please go to website and sign up the Slack channel as well as register your team. Then we'll have a great competition. Also see you at the CVPR.
Yes, fantastic. We will keep an eye on this one and give you some updates about the competition as time goes on as well. Thanks so much to our guests, Wolong, Zhenyao, Xiaoye. Great job, everybody. Thanks so much for you watching out there. We wouldn't do this show if you didn't watch it, and so we really appreciate you coming out every Thursday morning here. We will see you next Thursday morning, same bat time, same bat channel. Please take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. Adios.
Thank you.